In this video, we'll be discussing the live programs of part A 18CSL48, and this video is just for the quick revision purpose, before exam. So if you like this video, hit the like button and don't forget to subscribe to my channel. First program, we have to multiply two 16-bit binary numbers. So take two registers and store those two numbers here. Then by using this code, we'll multiply those both numbers and store in R3. The next program is to find the sum of first and integer numbers. So for that we have to use a counter R5 as 10, and then we will store two numbers R0 and R1 as 0 and 1. Then we will add 0 and 1 and store in R0. Okay, so that the sum will be added and again 2 will be added. Then we'll make it as 3 and 3 will be added. Then we'll make it as 4 and 4 will be added. How many times we will do? We'll decrement R5 till R5 reaches 0. Okay, then if R5 reaches 0, get an address like R4 is equal to 0400 and store that value, which is the result in R0 in that memory location. Okay, of a number, first take that number, suppose that it's 5, and then copy the same number into another memory location. So two memory location will have 5 now. What we'll be doing in this loop is, first we'll be subtracting R1 value, so R1 will become 4. Then we'll multiply 5 into 4 and store in R3. Okay, we'll multiply both and store in R3, and then copy the value of R3 in R0. So what does R0 have now? This one means this multiplication value. So then what we will be doing, we will be again looping this and subtracting a value of R1. R1 had 4, now it will become 3. Then again we are multiplying 5 into 3 and storing in R3. R3 will transfer to R0. Again we are doing the same thing in the loop. 3 will become 2, and then we are multiplying the result with 2 and then storing in R3. R3's value is copied to R0. Like that we are doing until we reach 0. We are checking 2 times here. If it reaches 0, we have to stop the iteration. 16-bit numbers, first we have to go to the memory location, and in each memory location we'll be storing some number. Okay, and after that what we'll be doing, we'll be loading the first number in R4. Okay, so we have a counter here, and the first location will be there, which is 00 in R3. We are loading the value of R3 in R4. Okay, so the first element will be stored in R4. Then what we'll do, we'll add R3 to 4, which means we'll increment this value, and this memory location will be stored in R5. So R4 has first value, R5 has second value. Then what we'll do, R4 plus R5. So these two numbers will be added and stored in R4. Then what we'll do, we'll loop again. We'll add R3 to 4, so R3 will be pointing to this one, and this value will be storing in R5. Then again we are adding R5 and R4 and storing in R4. Like that we are again incrementing and adding this value to R4. Finally R4 will have the result, and that will be using address to see the store the result and see the result. To find the square of the number, we need to access the correct memory location of the table. Okay, in this table all the squares of the numbers are kept. So take the number which you have to calculate the square for, multiply that many times 4, because 4 locations are skipped here. After that we'll get the increment, add it to the base address, we'll get the location of the square of the number, get an address and store the result to see the result. To find the smallest or largest in an array, get the number, store the first element in R2, increment and store the second element in R3, then compare each of them. If it's larger, then directly decrement R5. If it's not larger, means R2 is not larger than R3, at that time store the value of R3 in R2, then again decrement R5. Finally get an address and store the result. To arrange the numbers in ascending or descending order, we have to use two for loops, outer loop and inner loop. Get the location of the first element and store it in R3. Get the location of the second element and store it in R4. Compare each of them. If we want ascending order, at that time the first number should be lesser, right? R3 should be less than R4. If it's lesser, move on to the next iteration. Else, exchange both of these values. How you will exchange? Decrement R2 to the first location, store it in the first location, then increment R2 and store it in the second location. After that's done, move on to the next iteration. Like this we will do how many times? 3 times. Okay, for counting the number of zeros and ones in two numbers, take two counters, one for counting 1 and another for counting zeros. Then how many data we have to calculate, that will be stored in R3, and the address of the first number, which is 3, will be stored in R5. Will be for counting the bits, rotate right R6. Each time check the value of last bit. If it's 1, skip this part and increment for 1, else increment 0 and skip this part. Each time decrement R5. When R5 is 0, check for the next number.